tutorial in R. We're going to look further at how we can visualize data, and in particular we're going to look at scatter plots and correlations. So I'm going to make up some data set, and we're going to put ages of kids in the school, so age, we'll make that some vector, and for each age there's going to be a corresponding weight in the next vector we create. So just a small data set there. Now in the weight set, 12, and this will be kilograms, we'll say. 12-year-old might weigh 40, 14-year-old might be 46, 15-year-old a bit lighter. As I say, just making these numbers up, but this is just to show you how you can use these techniques or a real data set when you do come across one of those. Okay, so now, like we did in the last video, we used the plot command and we plotted x from, I think, -10 to 10 and y is equal to x squared. I mean, we knew what that would look like, but this plot command we can use for age versus weight. Let's see what I've done. I haven't put enough data sets in to weight, so let's see how many we got. We got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Alright, so I'm a little bit behind. Yeah, so this one's actually for the 17-year-old. This is really going to mess up my data, but anyway. So the 17-year-old can be 73 kilograms, and the 12-year-old 86. Anyway, now we'll plot age against weight. And you can see we get some points plotted here for each of the ages. We haven't really got enough points to see any sort of relationship. You can see generally it seems to increase as we get older, almost non-linearly, to be honest. But the point is, from this scatter graph, we can see little relationships, but we can't be sure there is some sort of relationship between these variables. So we might want to dig a little bit deeper and use the correlation function. Age and weight, and this gives us a number, and this is the Pearson's correlation coefficient, which will always be between -1 and 1. The closer it is to 1, there's a strong positive correlation. If it's close to -1, there's a strong negative correlation, and anything near 0 just means there's no linear relationship between the components. It doesn't mean there's no relationship between them. For example, when we did y equals x squared, there's no linear relationship there. To get a coefficient, correlation coefficient of pretty much 0, but probably exactly 0 if we're taking our data points symmetric in the range we're looking at. But there is a relationship between those. I mean, y is determined from x, so there is a relationship. That relationship is not linear, so that's all this coefficient is looking for. So that's how you find it. in the next video we might start going into some hypothesis testing, so we'll look in more detail about correlations and also some other hypothesis tests. If you have any questions about R, please be sure to let me know down in the comments, or any other maths queries. If you did enjoy this video, please be sure to like and subscribe, and I will see you in the next one.